2022 World Cup Simulator using data science, with Python. Here's how I built a World Cup simulator and predicted the next World Cup winner. Disclaimer 1. Please don't use this for betting purposes. This is just a mathematical experiment made by a data scientist. I am not a tipper and I don't want to give you any suggestions on your bets. Disclaimer 2. This article is not related in any way to all the Qatar events that are happening these days, and it is not a sponsor or anti-sponsor of the FIFA World Cup 2022 in Qatar. So, after we won the European Cup in 2020, Italy is out of the World Cup. This is a huge letdown for me as an Italian. Our nation is one that eats, sleeps, talks, and plays football every day. I remember being a young child the last time Italy won the World Cup. I wasn't even 10 when I watched the game with my family in Rome on a small television at my uncle's house. I am 25 years old now, and live in the US, but that memory is permanently inked in my soul. With all the controversy that this Qatar World Cup is bringing us, I still believe that the World Cup itself is a magical moment. The thing is that today I am a researcher too, and I use data science every day of my life. I spent the last 4 years of my life doing data science and machine learning at the university, and I am completely in love with it. So what I decided to do is build a data science algorithm. I wouldn't properly call it machine learning, but you will be the judge, to predict the winner and the whole tournament of the next World Cup edition. So let me tell you, in a few words, what you'll see in this article. We will build some kind of probability function for the results of the matches. We will run a simulation based on the probabilities we extracted. We will run the simulation multiple times and extract some statistics. Let's do it then. 1. First steps. Let's import some libraries first. The dataset that I used is a dataset of the matches and the number of time a national team has won or has passed the group stage, as we will see. Now let me do some explorations. Let's start with the obvious and look at how many times each team has won the World Cup before. So we know that already, right? Brazil won 5, Italy won 4, and Argentina won 2. Diego. Another cool thing we can explore is related to the fact that, in the matches dataset, we have the stage of the tournament as well. It is interesting to explore it because the number of times that a country passed the group stage is obviously indicative of the quality of that team. Let's give it a look. So we have a lot of group stage matches but only a few elimination stages. That makes complete sense because, of course, you have multiple groups but only one eliminatory phase. 2. Modeling the probability distribution. Now that the boring part is done, let's get into the details of how we are going to simulate this World Cup. We have our teams and their matches. Let's say that you have Team 1, T_1, and Team 2, T_2. What is the probability that Team 1 will win the match? It is the same for T_2 in the draw. Now, about the draw, of course, two teams can draw in the group stage, but they cannot draw in the elimination stage. I will tell you how to deal with it later. Similarly to what I said before, we can find the probability of T_1 winning in general like this. It is, of course, the same for drawing or losing. To do that, we need the following column for the matches, which we called result. Now we have to select the team for the Qatar World Cup. It is not a great deal of work, and we can just copy and paste it from the website. I did it for you. Now we have to match the data that we have with the team list. We have to make sure that we have all the teams that are going to be in Qatar in the dataset. So Qatar is, ironically, the only team we don't have in our dataset. We'll deal with this later. Let's add a Qatar_probabilities dictionary for now, which is a kind of made-up realistic probability of how many games Qatar can actually win in the World Cup. Now if we want to do the probability conversion, let's use the following function, and let's plot some random results. Now, this is all cool, but we need to do the probability for the matches, not for the single teams only. We are applying the rule above in the following way. Now, this probability only works if the two matches have a history of matches. This, for example, works in France and Italy. But what are we going to do in this case? Now, this is a real question. I don't have the answer because it is hard to automatically predict the outcome of two teams that have never played each other. What we can do is build a score for each time and compare the two scores to convert them into a probability of Team 1 winning, Team 2 winning, or the two teams drawing. I think that a good score for a team is the number of, normalized, times that the team has passed the group stage. This is, of course, a good point that indicates the quality of a team. We will call it a score of 1. Another important thing to consider is the number of times that a team has actually won the World Cup. We will call it a score of 2. As score_1 is between 0 and 1 and score_2 can be 2, 3, or 4. Let's multiply this by 0.5. So given a team T, we will have. So if we have two teams, T_x1 and T_x2, and we define the probability of T_x1 winning as P_x1, T_x2, we can say that. But this definition of probability doesn't allow us to draw. So we will rather say that the probability of drawing between two teams that have never played a match is fixed, let's say at 0.10. Then we will say that, and the probability of them drawing is. Let's implement this idea in the following way. 1. Function to get the score of a team. 2. Function to convert the scores of two teams into a probability. As we can see, the score of Qatar is 0.09. I got that from the first 0.25 quartile of all the score 1 distribution. This is a reasonably low value for a team that never played in the World Cup. 3. Function to extract the probabilities of the results between two teams in a match. For example, I also made sure that it is not possible that a team has a 100% of probability of winning against another by adding some small probability in losing and drawing. 3. The fun. Now it is time to make our model run. We have to build the exact groups for the Qatar World Cup. We will make this group run, and a team will win, draw, or lose based on the probability we have built. We will also build the algorithmic elimination stage. First team of Group A versus the second team of Group B. First team of Group B versus the second team of Group A. We will run this algorithm multiple times, and we will pick the winner. Let me do this step by step. Let's define the groups, and group them together. This, for example, is the probability for Group B. Based on these probabilities, we can run the simulation in the following way. This is for a given group. This is for all the groups. Let's run the simulations for the groups. Let's show some results. These are all. I don't know about you, but I think these results are pretty realistic. Let's move on. From the groups, this is the eliminatory stage, and this is the whole tournament simulation. This is an example of the whole tournament simulation, and we can run this for 10,000 times. It takes a while. The following are the winner statistics. Some of them are surprising: Senegal, Costa Rica, Ecuador, Brazil and Argentina not included. Some of them are pretty reliable: Spain, Germany, England. We can slightly alter the function to determine the winner and runner-up. This is actually pretty exciting, and we can conclude a lot of things. The Netherlands, for example, plays a lot in the finals, as does England. Nonetheless, Spain has far more finals victories than either team. We can go on and keep analyzing. Iran, for example, reached the final, at least once, but never won. 4. Considerations. In this article, we simulated the next World Cup winner. We actually simulated the whole tournament, and we extracted the winner and the second team. We did that by doing the following: extracting the statistics of the teams, building a score system for the teams with less to none record of playing against each other, building the algorithm of selections of the groups and eliminatory stage, run the simulation multiple times, extract the results. There is a lot of room for improvement. For example, we can consider the actual quality of the teams, considering their players, their coach, and their form. In the meantime, let's enjoy some good football. Smiling face with hearts. 5. Conclusions. If you like the article and you want to know more about machine learning, or you just want to ask me something, you can. Follow me on LinkedIn, where I publish all my stories. Subscribe to my newsletter. It will keep you updated about news stories and give you the chance to text me to receive all the corrections or doubts you may have. Become a referred member, so you won't have any maximum number of stories for the month and you can read whatever I and thousands of other machine learning and data science top writers write about the newest technology available.